All right, we're going to keep going here with these online lessons. So today we're talking about the converse of the Pythagorean theorem, and I'll talk about what that means in just a moment. But real quick, let's just review. The Pythagorean theorem says that what are called legs, these sides of a right triangle that make up the right angle, if I square those and add those together, it equals this side squared, which is called the hypotenuse. This down here is a new something, so you need to pause and write this down. This isn't necessarily related to right triangles, but it is important. It's called the triangle inequality theorem. It says the sum of the lengths of any two sides of a triangle has to be greater than the length of the third side. So let's take a look at what that means. But first, I'm going to start adding these things. I'm a big fan of internet memes. So I don't know, just something to make the videos a little more entertaining from time to time. I'll try to throw these in here every now and again. So here is just a moment of truth, something for you to think about. Guy went to the moon, 5 photos. Teenage girl goes to the bathroom, 37 selfies. Something's wrong with this world. All right, so using the triangle inequality theorem, is it possible to construct a triangle with the given side lengths and explain? So what you're doing when you're doing these problems is you want to make sure that the sum of any two of these side lengths must be greater than that. In other words, 6 plus 5 must be greater than 4. That's true. 6 plus 4 must be greater than 5. That's true. And then 5 plus 4 must be greater than 6, which 9 is greater than 6, so that's true. So yes, this can be a triangle. Let's try this one over here. 7 plus 15 needs to be greater than 6, which 7 plus 15 is. 7 plus 6 needs to be greater than 15. Well, 7 plus 6 is 13. That's not greater than 15. So this one is not a triangle. And when it says explain, just showing the math is good enough. Okay, I meant to say yes on this one, but just showing the math is good enough for this. Now I want you to think about why this would be the case. If I have a side length that's 7 and I have a side length that's 6, at some point these two side lengths have to touch each other. Well, if this side length right here is 15, let me go ahead and label these. If this is 15, if I lay these flat all the way down, then all of a sudden it's the same line, and they still don't touch. Those two line segments don't. Okay, so they have to be longer in order for it to make a triangle. All right, so here's one for you to try. Hopefully on this first one you find no. And on the second one, the answer is yes. All right, so hopefully you found that. If you're not sure of anything, make sure you bring your questions back to class. All right, so a converse is basically just taking something and reversing it. So the Pythagorean theorem says that a triangle is a right triangle if a squared plus b squared equals c squared. Okay, so you could use the fact that a triangle is a right triangle, not if, but if a triangle is a right triangle, then this is true. The converse is the opposite of that. Okay, so if this is true right here, then it must mean it's a right triangle. In other words, you're able to take side lengths and determine if it's a right triangle as opposed to being told it's a right triangle. Here's what I mean. So we've seen problems like this where it's told to you that, hey, this is a right triangle. Find that side length. What you're using the converse for is, hey, we have a triangle here and it's this. Is that a right triangle based on those side lengths? So based on those side lengths, if you're determining whether or not it's a right triangle, that's using the converse. All right, so here's how this plays out. It says determine whether a triangle is a right triangle and explain. The way you would do this is, first of all, the longest side is always your hypotenuse. It's always the c value. So I have a squared plus b squared. Whoops. Let's erase that little mistake. Maybe. Eraser. And back to yellow. A squared plus b squared equals c squared. This is always the largest number of the three. So this 7.5 squared needs to equal 6 squared plus 4.5 or 4 5/10 squared. And then you actually go through this and see if this is true. So that's 36 plus, let's see, 4.5. 36 plus, what's happening? 20 and 25 hundredths needs to equal 56 and 25 hundredths. So then we go ahead and add these things, which this is 56, 25 hundredths equals 56, 25 hundredths. They are the same value, so the answer is yes. When it tells you to explain, that's what this is right here. Okay, I'm proving that this is a right triangle by using the Pythagorean theorem. All right, so this next one, let's take a look. You go ahead and try both of those. All right, so hopefully you found that this first one is a yes, and then that the second one is a no. It does not fulfill the Pythagorean theorem. All right, so here it says a land surveyor determines that a triangular plot of land has boundary lines that are 400 yards, 600 yards, and 720 yards in length. The 400-yard boundary line runs east to west. Determine whether either of the other two boundary lines runs north-south. If something runs east-west, and then something else is going to run north-south, then that's what we would call perpendicular. Okay, and anything that's perpendicular is going to create a right triangle. So it says determine, it says the 400-yard boundary line runs east to west. So we'll say that this is 400 right here. And then it wants to know whether either of the other two boundary lines runs north to south. Well, if this is perpendicular to this and this makes the right angle, then this side has to be the 600, which means this right here is the 720. In order to determine if this runs north to south, we have to see if this is actually a right triangle. Does this make a right angle? And if it does, then it's perfectly perpendicular to this line, which means that, yes, this would run north to south. So we plug these values into the Pythagorean theorem and see if it works. So here 400 squared is 160,000 plus this is 360,000, and we want to know, does that equal 720 squared, which is 518,400. Well, I could already tell you right now, because this one has that 400 right there, that these are not going to be equal to each other, but we could go ahead and add them together just to make sure. This is equal to 520,000, and that is not equal to 518,400. So the answer is no. Okay, none of them run north to south because it doesn't make a perfect right angle. All right, let's take a look at one for you to try. So go ahead and draw that out. Try that on your own. And hopefully when you're done with that, you find that the answer is yes. That does work for that particular one. Okay, so here where it says explain, just make sure that's where you're showing that it fulfills the Pythagorean theorem. All right, that's it for today, so I will see you in class. We'll do some problems.